velocity form and position form of algorithm that we have to see. Position form and velocity form of PID, digital PID algorithm, digital PID controller. Digital PID controller. Here, E of t, you know, E of t equal to Y of t, that is output minus set point. That you know, E of t. What is E of k? E of k is in digital, that is Y of k, kth sampling instant minus set point at kth sampling instant. So this is in digital form. Digital. So controller output also in analog we will say M of t. Here M of k. M of k. Let us write first analog form. M of t equal to kc multiplied by E of t plus kc by ti integral of E of t dt plus let us write for PID kc td de by dt plus bias. So this is the analog controller output, but not E of t. E of k is what? K at kth sampling instant, the error equal to output at kth sampling instant minus set point at kth sampling instant. That is E of k. Now replace this in a digital form, then you will get M of k. M of k equal to kc E of k plus kc by ti. This integration becomes summation. Summation means we have to multiply by sampling period t. The integration becomes summation of E of k plus kc td. d by dt means change in error per unit time. dt is, let us approximate this dt is sampling period. d means change in error, that is E of k minus E of k minus 1. Past error. This is present error. This is past error. Past error. The difference between the two is change in error, dE by dt. Therefore, we can write kc td multiplied by E of k minus E of k minus 1 divided by d. Instead of dt, we can put sampling period. This is approximated in digital domain. This is the digital position form of controller plus bias. This is position form of controller. Position form of controller. Here, this is called total controller output. This is total controller output. So this can be written for delta M, change in M. Change in M means previous sampling period, what is the controller output? At present, what is the controller output? The difference between the two is change in controller output. If you know the change in controller output, we can add it to the previous controller output. Suppose previous controller output is 12 milliamps. At present change in controller output is 0.1 milliampere. Therefore, the new controller output is 12.1 milliampere. That's all. We have to add these two. That's all. If you add these two, you will get new controller output. Like that, we are going to find delta M of k. To find delta M of k, we have to find M of k minus 1. M of k is available. If you find M of k minus 1, the difference is delta M. So delta M equal to what? Delta M of k equal to M of k minus M of k minus 1. So what is M of k minus 1? From here we can write M of k minus 1. M of k minus 1 equal to what? M of k minus 1 equal to kc multiplied by k minus 1 plus kc by ti multiplied by t, sum of here minus infinity to k. Here also minus infinity to k minus 1, because previous controller output E of k minus 1 plus kc td divided by t, E of k minus 1 minus E of K minus 2 because previous controller plus bias. So therefore, delta M of K means change in controller output equal to what? M of K minus M of K minus 1. If you subtract, if you from this, what you will get is, for first term, what you will get? Kc multiplied by E of K minus E of K minus 1. E of K minus E of K minus E of K minus 1. Plus, if you consider this term and this term, what you will get is, up to K minus 1, if you subtract these two, up to K minus 1 getting cancelled. What is the remaining? What are the constant terms? Kc by Ti multiplied by T. Here up to K minus 1. Here up to K. The last term only is there. That's why E of K. Only. Plus Kc Td divided by T. And here if you subtract, E of K will be there. E of K will be there. E of K minus 1. Here also minus 2 E of K minus 1 plus E of K minus 2. That's all. This is the velocity form of PID controller. Velocity form of PID controller. What is the advantage? There is no integration. The integration becomes summation. No, that is removed. That's why no integral wind up problem will not be there. That is the advantage of velocity form. No integral wind up because no integration is there. Integration is removed. That's why you will get delta M. Delta M has to be added to previous controller output. That's all. That way it is written in this program. That's why here PI controller output is written like Kc multiplied by delta E. Delta E means what? Change in error. E of K minus E of K minus 1 is called E of K minus 1 is called delta E. Delta E. T by Ti multiplied by T. T equal to 1 means that's why it is not here. Otherwise, here we have to include T multiplied by error. This is integral term. Integral term becomes E of K because summation goes off. So that is change in M. So x1 is previous value equal to M plus bias. M equal to M plus bias. We have to write one more statement. We'll see that.